So welcome to a new series I'm starting off where I'm going to work out 5 SAT math problems a day. The idea behind this would be that they should be relatively short videos. You can pause the video once the problem is posted up there, attempt the problem, and then play the video to see the explanation, see if you got the right answer. I will try to show a few different explanations. There will be a link to a PDF of this, which has been released by the College Board. There will also be a link to the College Board website where they have 8 full practice tests posted for you to use. So we'll get started. In this problem, if x minus 1 over 3 is equal to k and k equals 3, what is the value of x? So as a math teacher, the way I would attack this problem is I would just replace this value of k with 3 and get the equation x minus 1 over 3 is equal to 3. And now I can solve this two-step equation. I want to isolate x. There's a minus 1 and divided by 3 in the way. So I will multiply both sides by 3. So those cancel out. That leaves me with x minus 1 is equal to 9. And then I can add 1 to both sides. And from that, I get x is equal to 10. D. Now, alternately, and this is also a good option, I could have, if I didn't think to do this, just tried all of these in there, and I could try 2 minus 1 over 3. Well, that's 1/3. That's not equal to 3. I could have tried 4 minus 1 over 3. 4 minus 1 is 3 over 3 is 1. I could have tried 9 minus 1 over 3. That's going to be 8/3. And then finally, when I get to 10 minus 1 over 3, I do get to 3. So if you can't think of how to solve it one way, you could always, in some cases, just check all of the answers and see which one is correct. On to question 2, give it a shot. Okay, for I equals the square root of -1, which is what we define I as, what is the sum 7 plus 3i plus -8 plus 9i? And so this is just combining like terms. There's really no more to it. Now you can, since there's a plus between them, just write it out like this: 7 plus 3i plus -8 plus 9i. Some people really love to have parentheses around that -8. That doesn't really matter. And then you can combine the like terms. Say, if you have 7 plus -8, that gives me -1. We have 3i plus 9i, that gives me 12i. That might be a little bit difficult to see. So -1 plus 12i. Now, another way I've seen this done, a popular way to do complex addition, is to write this vertically. So I've seen a lot of students that may prefer to write 7 plus 3i plus -8 plus 9i. And now they're lined up a lot like the addition problems we're used to seeing, where I would do 3i plus 9i, get 12i. 7 plus -8, get -1. And there's our answer. Give this problem a shot. Okay, on Sunday afternoon, Armand sent M text messages each hour for 5 hours. Tyrone sent P text messages each hour for 4 hours. Which of the following represents the number of messages sent by Armand and Tyrone on Saturday afternoon? So we have two people here. We have Armand sending M texts per hour for 5 hours, and Tyrone sending P text messages per hour for 4 hours. And so what we have is we have a rate of M texts per hour and 5 hours. And we have P texts per hour times 4 hours. And you can look at the units here and notice that in this case, the hours will cancel out and I'll be left with exactly texts. So I would end up with 5m from Armand plus 4p for Tyrone, which gives me C. Okay, give this a shot. So, Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left, D is the number of days she has worked that week. What is the meaning of the 108? So in here, if I start thinking of this, let's count this, so 7 days in a week. So we'll say day and phones left. So at the very beginning, she has worked 0 days. And I can see that when I put 0 into here, I get 108 minus 23 times 0, which will give me 108. Now that already tells me the answer, but let's just follow along and see what the 23 means as well. After 1 day, she would have 108 minus 23 times 1, which is going to give her, let's see, 85 phones. After 2 days, she would have 108 minus 23 times 2, which should give me 62 phones. And I'll put a little dot, 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 a little ellipsis here, so this pattern continues. And you can see the 108 is the starting value. It's the y-intercept. I could write this as sort of y equals negative 23x plus 108, and you can see that's my slope, which is my unit rate, how many phones per day. And this is my b, my y-intercept, sort of where I start. So let's see which one. Kathy will complete the repairs within 108 days. No, that's not what's happening. You see, we'll be done long before 108 days. It looks like maybe at the end of 3 more days, so 5 total days, she'll be done. She'll be done a little bit earlier than that, but she'll be done by the end of the 3rd day. She starts each week with 108 phones to fix, and you can see before she works, there were 108 phones, so that looks like a promising answer. This is not 108 per hour, it's actually 23 phones per hour that she fixed, or not even per hour, 23 phones per day. Okay, give this one a shot. So this is our final problem for today. I have x squared y minus 3y squared plus 5xy squared minus negative x squared y plus 3xy squared minus 3y squared. And I say which of the following is equivalent to the expression above. So in here, I have a couple options. The way I like to do it, I see this negative in front of an expression in parentheses, which means that I'm really distributing a -1 to all of these terms. I don't have anything up here, so I can write this out as is. So the first portion here, this portion here, is just as is. The parentheses do not change how that works at all. So x squared y minus 3y squared plus 5xy squared. However, the other part, we do change it with this negative. So a negative gives me plus x squared y. A -1 and a +3 gives me a minus 3xy squared. The -1 and the -3 gives me a plus 3y squared. And to wrap it up, I just combine my like terms. So I have x squared y, adding those up, I get 2x squared y. As a note, when I'm adding or subtracting, I can change the coefficients, but the exponents and variables will stay the same. Notice I have -3y squared and a +3y squared, so those cancel out. And now I have 5xy squared minus 3xy squared. Those are like terms. So I get a plus 2xy squared, which leads me to, let's see, 2x squared y plus 2xy squared. That looks promising. Now, like the earlier problem in this, I have seen people that prefer to write this vertically. I just need to be careful. So if I were to write this vertically, I could write x squared y minus 3y squared plus 5xy squared. Sorry, I'm flipping the colors here. And then I can put minus, and I just need to line up the correct term. So I have a negative x squared y, I have an x squared y, so I have negative x squared y. I have a 3xy squared. That's actually going to align with this term here. And I have a negative y squared, negative 3y squared, which will go right here. And I can do this work right here. And notice x squared y minus negative x squared y gives me the 2x squared y. Negative 3y squared minus negative 3y squared cancels out. And 5xy squared minus 3xy squared does give me 2xy squared. Same answer.